Okay, and I think we're live. Hi, everyone. Welcome to another book reading club session, this time with a new book called Hibernate Tips by Thorben. If you guys don't remember, we already did an introductory session to this book when we actually did the book launch for the Hibernate Tips book. So we're now very happy to have Thorben here again with us to go into a more detailed review about the book. Before we go into that, let's just introduce myself. I'm Roberto Cortez. You probably already know me about the old book reading club sessions. Work from a company called Tommy Tribe, which develops the awesome Tommy server. And with me, I have my colleague Ivan. Say hi to the audience, Ivan, and introduce yourself.
Hi everyone, my name is Ivan from the Bulgarian Java user group. I work for a small consulting company called Vida Software, and I'm one of the main organizers of the JPA conference, which is next week, and we have Roberto as our speaker there.
Yeah, thank you for having me. It's a pleasure for me to go there.
Great, and let's introduce our guest again. It's Thorben Janssen. Thorben, would you please share a few words about you?
Yeah, sure. So, well, I'm Thorben, and some of you might know me from my site thoughtsonjava.org, where I write about, but mostly Hibernate and JPA, and I'm also the author of the book we want to talk about today, called Hibernate Tips, which is a cookbook for Hibernate. Most of the recipes in there can also be used with standard JPA. And well, I'm using Java Enterprise and Hibernate since about 15 years now, and used it in lots of different projects of different sizes with different performance and feature requirements. And over the years, I saw that there are a lot of things you can do with Hibernate if you understand the framework and if you know the features that are available. And if you really know the capabilities of Hibernate, you can either use it to really quickly implement a small application that is just used by a few users, or you can spend some more time and implement a high-performance application that's used by hundreds or thousands of users. And you just have to understand what's going on internally and what are the effects of things that you are annotating to achieve both tasks. So it's quite interesting.
Awesome. And so what was your main motivation to actually write this book?
Well, everything started about one year ago when I started to write Hibernate tip posts on my blog. And the idea for that was that I got a lot of questions from my readers, and a lot of people asked the same questions. So I thought, well, why not write a quick blog post about that? And I wrote them in this typical recipe style where you have a problem statement and you provide the solution for that with a few code samples, but not with a lot of explanations of the general concepts, just with a focus on the specific problem and how you can solve that. I did that for quite a while, and then decided to continue this format in the book. And the book came out about 1.5 months ago on the 4th of April, and it now contains more than 70 tips. More than half of them are exclusively in the book, and the other part was already published on the blog.
Great. So basically, where can I get the book actually?
You can get the book on Amazon, or you just go to hibernatetips.com, and you can find there a link to the Amazon page, or you can buy it there in a PDF version.
Okay. So as far as I understood, basically you have a book where you have like these multiple tips to deal with Hibernate in a very specific way. Are these only like specific for Hibernate, or are they also can be used to other more generic JPA implementations?
Most of them can be used with JPA. But there are, of course, also others that are using Hibernate-specific annotations or features. And that's the reason why I called it Hibernate tips. But I would say most of them can also be used with JPA.
Okay. Will you consider actually writing a book just to grab all of the JPA stuff and put it into a single book as well?
Well, that would be an idea. Yeah, maybe I can create another version of the book that's then called JPA Tips or something like that.
Yeah, awesome. So now you have a second book to write, and then we'll be here then for you to review it and talk to our audience about it. So while we start, now we're gonna start and dive deep into some of the book topics. I think my colleague Ivan has a couple of questions that they already have prepared, while I'll try to see if we have any questions coming from our audience. So please, Ivan, go ahead.
As always, we encourage our audience to join our channel on IRC or the virtual JUC page on the meetup. And before that, or while you are still feeling shy, I have prepared a few questions to Thorben on the first half of the book, which I guess are the chapters setting up Hibernate, basic mappings, and advanced mappings. At least I have stopped there, but you may ask any question regarding Thorben's book, no matter whether it's this half or the next half. So let's start with setting up Hibernate. While I develop my application, when I configure at least JPA in persistence.xml, a common practice for me is to print the generated SQL so that I can see whether it is effective or whether I have some bugs in setting up the queries and the insert statements. By default, if I remember correctly, by default, if the SQL contains parameters, Hibernate Entity Manager doesn't print their values. I guess, if I remember correctly, Eclipse Link printed the values, but Hibernate Entity Manager doesn't do that. Is there a way to make it print the parameter values as well?
Yes, I show that in the log SQL statements chapter. Let me share my screen, and then we can have a look at the example project. So you should see my screen now. So you basically have two options to activate the logging of SQL statements. You can either use the parameter hibernate.showSQL in the persistence XML and set that one to true. And that is the approach that you find most often on Stack Overflow or everywhere else on the internet. But that's not the approach that I would recommend, because to activate or deactivate that, you have to edit your persistence XML file, and you can't do that without building and deploying your application again. And Hibernate uses standard out to write the SQL statements if you set the show SQL parameter to true. So you can't configure that with your logging configuration. It's much better to use the log4j or the logging configuration. Here's a log4j properties file, and you can see here that I use org hibernate.sql and set it to debug to activate the statement logging. And you can then also activate the log outputs for the parameter values by setting org hibernate type descriptor SQL to trace, not to debug, to trace. I'm going to now run the test case. You can see here the parameters. So here's the SQL query that the test case performed. It just selects an author entity by ID. And down here is the output for the bind parameter. So this is the parameter that I provide to the query, the author ID. And yeah, these down here are the properties of that are set for the entity.
Yeah, and if you scroll a little bit up, you'll see also the insert statements.
Yeah.
There's the one that I'm always looking for.
Yeah, these are the insert statements. But for the example projects for the Hibernate tips book, I took a very simple approach to initialize the test database, and that is something that you can use for test databases, but they better not use for any production systems. Since JPA 2.1, you can use JPA schema generation and database initialization feature. So here I just added this parameter to the persistence XML file, which takes Hibernate to execute the data.sql file at startup, and that one contains these insert statements up here.
Cool.
Okay.
Okay. Anything from the audience, Roberto?
Yeah, please go on.
Okay. So going to the next chapter, which is the basic mappings chapter. You spent some time talking about generating primary keys.
Yeah.
For the DB entries in your applications, and do you usually let Hibernate actually generate the primary keys, or you handle the primary keys manually? Or if you use a generated value switch strategy, would you recommend in what situation?
So in general, I use one of these generation strategies to create primary key values. And where you can choose between 3 different strategies, which is either identity that uses an auto-incremented column on the database table, or you can use a sequence, or you can use a table which simulates the behavior of a sequence. And I always recommend to use the sequence. The table approach is something that you don't need anymore, because almost all databases either support sequences or auto-incremented database columns. And the table strategy is just for the cases where you can't use any of the other 2. The identity strategy, which uses the auto-incremented database column, is a popular approach if you ask a DBA, for example, because databases can handle this pretty efficiently. It seems to be easy to use, but it has a drawback when you use it with Hibernate, because Hibernate needs the primary key value internally. And that means that when you persist a new entity, Hibernate will execute the insert statement immediately. And that prevents Hibernate from using any performance optimization techniques that depend on delaying the execution of the insert statement. That means you can't use JDBC batching, or, well, even a simple use case like you create a new entity, call the persist method with it, and a few lines later you change one of the attributes of that entity. In most situations, if you don't call the flush method or execute any database query between the persist and the update operation, in all these situations, Hibernate will perform only one insert statement. So it changes the value of the entity before it's persisted, and then it uses the new value with the insert statement. If you use the identity strategy, then Hibernate already performed the insert statement when you called the persist method. And as soon as you change something, Hibernate has to perform another statement. So it's a lot better to use the sequence approach if it's supported by the database. And in these cases, you can either use Hibernate's standard sequence, or you define your own sequence, and then you can reference that in your entity mappings, and Hibernate calls that sequence. And Hibernate provides several optimization techniques. They are like, it can calculate some of these values itself. So you increment the sequence, for example, by 50, Hibernate requests one sequence value, and then counts it up until it reaches the increment amount. And that means that you can create or persist 50 new entities with just one select statement that gets a new value from the database sequence. So yeah, in general, I recommend to use one of the generation strategies, and if possible, to use the sequence strategy. That's the one that's the best optimized on the Hibernate and on the database side.
Well, and will you recommend to use like different configurations based on the database engine that you're running with your application?
In general, yes. Well, it depends. If all your databases that you want to use support sequences, then I would always use sequences. I mean, nowadays almost all databases use support sequences, so you don't really have to worry about that. If you're using a database that doesn't support sequences, then you would need to use different configurations for that. And you could do that, for example, by annotating the entity with generated value annotation and set the generation strategy to sequence. And for the system that has to work with a database that doesn't support sequences, you can provide an additional mapping XML file which overrides the annotation and sets the generation strategy to, well, most likely identity. As I said, table is almost never used nowadays.
I see. Is there any situation where you will require to use a table?
Yeah, only if your database doesn't support sequences and doesn't support the identity strategy. So no auto-incremented columns and no sequences. The downside of the table approach is that Hibernate creates a database table and stores there the last primary key value. And if you persist a new entity, Hibernate will request will select this row from that table, put a lock on that row, and increment the value by 1 and update the row in the database. And this row will be locked until Hibernate commits the transaction. And that is just a horrible thing if you want to use your database with a lot of users in parallel. Because you always place this lock on the primary key table. And that basically puts all your user requests in a sequential order, which is never a good idea.
Of course. Yeah, anyway, I think that's a very good insight on how the different generation strategies work and where should you use one or the other, even though most of the times you want to use sequence, and there's a couple of cases where you might want to use something different.
Yeah.
We don't have any questions so far, so please, Ivan, proceed with your next one.
We have a very shy audience today.
Yeah.
I wonder why. Okay, so my next question is about relations, and especially about one-to-many. As far as I got from a few of your tips, you suggest that the usage of one-to-many is not really preferable. And you talk about
it depends.
Yeah, it always depends.
Yeah. So it's not preferable if you have a lot of entities on the many side. If you know that you have something like the typical order item example where you expect maybe 10 or 20 items in one order, that's fine. But if you have a use case where you have thousands of entities on the many side, like you have a product in your product catalog, and then you have a sold product in your customer data that links to the product. Then I would only model this association from the sold product to the product, because there it's a 2-1 association. That can be efficiently handled by Hibernate. But if you model that also as a 1-to-many association on the product, Hibernate would need to perform a query and fetch all these thousands of entities as soon as you call the getter method that maps the association. And that is something that's extremely dangerous. I mean, I had that in one of the applications I've worked on in the past, and everything seemed to be fine until the application got deployed to production, and the database didn't contain a few hundred, it contained a few 100,000 records, and we had quite some performance issues when Hibernate tried to fetch several thousand entities and load them into memory. One of the reasons why you might want to model that is that with plain JPA, you can join entities that have no mapped association. So as often, you have to decide what's the bigger pain. Is it the risk that you might call the getter method at some place in your code where you shouldn't do that? Or is it that you can join the association in your JPQA queries?
Well, but when you also do the join, then you also will get like 1,000 records or multiple, like as many records you have on the table, depending on the join criteria, right?
Yeah.
So
yes, working with these kinds of associations is always tricky. And you have to be careful with that. But it's in general, it's easier to handle them within your SQA statement than within the business code, because it's, well, for us it feels just natural to call a getter method on an entity. I mean, it's just an object, has a getter, sure, just call it. But we, especially when we use the domain model object somewhere in our business code, we often don't think about the effect that these method calls can have. And if there is an association that contains that many entities, I in general recommend to not model it as an association so that there's no getter method for it. And if you need them, then you can write a JPQA query, for example, use pagination and don't fetch several thousand, but just, I don't know, 20, 50, maybe a few hundred of these entities. I mean, there's always no situation in which you really need thousands of entities. The user doesn't want to see that. You can't handle that amount of data, so you have pagination in your UI anyways. And if you think about doing that in your business code to process the database records in any ways, then doing that in your database with a native SQL query is almost always the better approach.
Okay, so your recommendation will be to, in those cases when you have like thousands of entities, you'll just do like separate queries to load whatever data that you need, even avoiding sometimes mapping that particular entity or that particular relationship into a JPA object?
Yeah, in general, yes. I would model it from the main as a many-to-one association, so that you only have the getter method for the to-one side, and then you can, well, you can still use it in that direction in your queries, and you can then perform the queries and get the data that you need. Yeah.
I see. Since we're talking about these one-to-many relationships, one of the things that I see happening the most with Hibernate or other JPA implementations, doesn't really matter, is the loading strategy, which can be eager or lazy. So,
yeah, sorry, go ahead.
Yeah, so a lot of people sometimes don't really understand the difference between both of them and how do they perform. So a lot of people sometimes have these performance issues based on their loading strategy, and then they get very annoyed that their application is not performing well, and they don't understand why. Would like us to explain the difference between both strategies and when should we use the one and the other?
Yeah. So you have basically two options. You can use lazy fetching or eager fetching, and that defines when Hibernate initializes an association. Eager fetching tells Hibernate to fetch the association together with the entity. So if you load an order entity and set the association to the order item to eager, then Hibernate would not only load the order entity, it would also load all associated order items. And the issue with that is that Hibernate has to trigger the additional queries, and it consumes quite a lot of memory. And Hibernate doesn't know if you will use that association or not. It will just load it anyways. Every time it loads an order, it loads the items with that if you set the fetch type to eager. If you use fetch type lazy, which is the other option, then Hibernate will only initialize the association when you call the getter method. So when you're using your code order.getItems, then it will perform an additional query to get all the associated items for that order, which is the much better approach. But you also have to keep in mind that the fetch type lazy is also the cause of the n+1 select issue, which basically describes you select with your first query multiple orders, and then you iterate through the order entities and call the getItems method for each order, and in each call of these getItems triggers an additional query. So you have the first query for the order, and then another query for the n orders that you got from the database. This is, well, if you look at several applications, you most often either find the eager fetching issue or you find the n+1 select issues. But there's a pretty simple way to avoid that. You can tell Hibernate when you load an entity to also fetch the associated entities that you need for your specific use case within one query, and you can do that with a join fetch statement, which is basically which looks almost the same as a normal join clause between your entities. Just instead of just join, you write join fetch, and then Hibernate knows that it has to initialize the associated entities with one query, which is the easiest way to avoid the n+1 select issue.
I see. And another thing that I also see happening, especially when using the fetch type lazy, is that you in some situations you end up running something called the lazy initialization exception, which also seems to confuse people a lot. So can you explain us why does that happen and how you can work around it?
Yeah, well, that happens when you load an entity, close the current Hibernate session, and then call the method that would trigger another query to initialize the association. That can, for example, happen if you have a web application. The business tier gets the order entity from the database, gives it to the to the web tier. While doing that, it commits the transaction and closes the session. And when then the web tier tries to get the items, then Hibernate will throw a lazy initialization exception. And you can fix that in the same way as you fix the n+1 select issue by just joining the required associations when you get the entity from the database. So join fetch statement is the easiest way to do that.
I see.
And not the open session in view pattern or anti-pattern.
No, better not.
Okay, so Ivan, can you please proceed?
Oh, it's again me?
Yeah.
Okay, dear audience, I'm running out of questions, so please be more active. Okay, let's go on to the next chapter about
Maybe they already knew everything there is to know about Hibernate. I mean, Hibernate's already been here for so long.
Yeah, they know everything. Okay, sorry for the stupid questions then. Okay, next one, it's on the advanced mapping chapter. So sometimes for auditing purposes, I have, in my entities, I have fields for creation time and last update time and so on, and I need to store those times in those fields. Is there a way to implement it somehow automatically with JPA or Hibernate without the need for myself in my update method or persist method to set explicitly the current timestamp there?
Yes, that is one of the Hibernate specific tips in the book. Let me share my screen. And I need a moment to find the update project. So there are too many projects. So the code and the Maven project you can see here is the example project that's linked in the book. So you can find a code sample for each and every tip in the book. And I now just can't find the project I'm looking for. Well, then I just explain it. So Hibernate offers two annotations called update timestamp and creation timestamp. And they do well exactly what you would expect from the name. They set the timestamps for the last create or the last update operation that Hibernate performed for that entity. And after you've annotated the entity accordingly, you basically don't have to do anything. Hibernate takes care of these timestamps, so the create timestamp gets only set during the insert statement and the update statements for each update. And then you can use them as any other read-only entity attribute.
Okay, and anything which is not Hibernate specific, but maybe more JPA?
Well, with JPA, you could use a lifecycle listener, for example, and yeah, you could use a lifecycle listener or a lifecycle callback that you perform in the and set the attribute there. So you could, for example, implement a method on your entity that sets the creation or update timestamp, and either annotate it with pre-persist if you want to set it before your JPA implementation persists the entity, or with pre-update to set it before the entity gets updated. And you would get the same behavior as with the Hibernate specific annotations.
Okay, great.
Okay, so basically you're saying there is like a standard way to do it, and you don't really need to use any Hibernate specific stuff.
Yeah, the Hibernate specific entities make it a little bit easier, but it's
shortcut.
I have an example for the pre-persist. Can you see my screen now?
Yeah, we can.
Yes.
Okay. So here's an example for the creation timestamp. So this author entity has a local datetime attribute called created@, and I implemented a method called initialize created@, set the attribute to the current datetime, write a quick log message, which you obviously don't need for a real application, but which will be nice when we run the test case. And then I just annotate it with pre-persist. And that tells Hibernate to call this method before the entity gets persisted in the database. And we now run this test case. You should see in the log file that here it is. So this is the message that I wrote in the method that was annotated with pre-persist, and we see here that it's got called, and for Hibernate is then just the normal entity attribute. So it's of course part of the in-that statement, and you can see here that the bind parameter is set accordingly.
Yeah, since we're now talking a little bit about some of specific Hibernate features, it's more like a generic question, but what will be the specific Hibernate features that will separate Hibernate from other JPA implementations?
Where there are quite a few that separate it from the JPA specification itself. But if you look at other JPA implementations, they most often offer similar proprietary extensions to the standard. So you can do most things with each and every JPA implementation. Sometimes the annotation have a different name, but the concepts are generally the same.
Well, I'll do the question in another way then. What will be a specific Hibernate feature that I would like to use in the application that I won't have on the standard? So what will make me actually go beyond the standard, actually do some specific stuff?
Yeah, right now it's probably the Java 8 support. So the JPA standard doesn't support local date, local date time, and the other classes from the date and time API. You can write an attribute converter for it to implement that yourself, but out of the box, you have no support for that in the JPA standard, which means that it gets most often mapped to an object and then stored as a clob in the database, which is not the approach that we would prefer to implement an efficient application and give the database a chance to handle the date as a date and use all the optimizations that they provide for that.
Sure.
Then you have a lot of other things that Hibernate offers on top of that. There's the stream method, for example, which provides a comfortable way to get a stream representation for your query result, but it also offers a huge additional benefit. If you just call the getResultList method to get your query result, then your JPA implementation fetches all records of the query result from the database. And if you want to process, well, if you have a huge result set, and if you then want to process them as a stream, that's not the most efficient approach, because the stream processes the records in the result set one by one. So there's no need to fetch a few hundred or 1,000 records in the beginning and then just iterate through them one by one. It's more efficient to use Hibernate's stream method, which is
is that like the JDBC scrollable result set?
Yeah, exactly. It uses it then scrolls through the query result and fetches the result set records in small batches.
So it's like the stream actually returns like a Java 8 stream, or it's just like a...
Yes, it returns a Java 8 stream. It's backed by I think it's called scrollable result, which is a concept that Hibernate implements for quite a while now. And it behaves in the same way as the JDBC result set, where you can scroll through your result and fetch that in multiple batches. Other features that Hibernate provides that are quite interesting are support for natural IDs, for example. So Hibernate provides a similar API as you know for primary keys. It also provides for natural IDs. Let me have a look. I should have an example for that. There it is. Let me share my screen and can have a look at that. So here we have a book entity, and I annotated the ISBN attribute with Hibernate's natural ID annotation. In most cases, we would model the ISBN number of a book as a natural ID in the database, and it would be the attribute that probably most of the people in the bookstore would use to look up a specific book, either the title, which is more human readable, or if they have the book and want to find it in the application, they would probably use the ISBN as a natural ID. So when we annotate it with natural ID in the in our Java code, then we can use Hibernate's natural ID support. So here you can see an example. I first get the Hibernate session. It's a Hibernate specific feature, so we obviously need to use the Hibernate session. And then I can use the by natural ID method to tell Hibernate that I want to get a book entity, and then I can call the using method multiple times, so once for each attribute that's part of the natural ID, provide the ISBN number here, and then just load the entity. Or if I know that my natural ID consists of only one attribute, then I can just call the load method and provide the value of the natural ID. And this part is pretty similar to the entity manager fetch, entity manager find syntax that we normally use to load an entity by the primary key.
I see.
Do you get automatically an index on those columns which are annotated with natural ID? I mean, if you let Hibernate create your tables, of course.
I think not. I think you need to set the index yourself. Okay. I'm not 100% sure about that, because in general, I don't recommend to use generating the database schema with Hibernate. You can obviously do that in example projects like here, like I use here for the book examples, or you can use it to create the first version of your database scripts. That's something that I recommend, for example. So model either your database and generate the entities, or model your entities and then generate the database script. And then the important part, you're not done with that before you not had a look at the generated code and adapted the database model and the entities until you have a version that works good for both systems. That's the most important part about that.
Yeah, so that's a very interesting discussion. I mean, so basically you recommend that you never use Hibernate to manage your database, right? Or at least you can do it for like the first version, and after that you should actually do the changes directly on the database and then adjust your model based on the database schema.
Yes. So my philosophy here is that when you implement a Java application that works with a database, you're basically integrating two systems with another. Sure, that's the most standard integration approach that we have, and we do that for, I would say, each and every application. So we are pretty used to that, but we are still integrating two systems that are using two different concepts. We have Java with an object-oriented concept, and then we have the relational table model. And there's a difference between that. And that means that we have to find a table model and an object representation that fits to each other, but that also doesn't create any issues in one of the systems. So it's not good enough to say, well, I'm a Java developer and now have a nice domain model. If we get a database, if we get a table model with that's inefficient in the database, then we will have a slow application. Or if we take the other approach and say, okay, I'm just modeling that on the database level, and we get something that is hard or inefficient to use in our Java world, then we have the same issues again. So there are two systems, and we need to find a way to make them work together.
I see. And one of the things I mean, this is probably a topic on its own, but do you recommend using any approach to manage the database schema itself?
Yeah, there are different approaches or different tools out there. So in general, I recommend to use version database scripts, and that simply allows you to define an update path for your database for the different application versions. And you can then use Liquibase or Flyway, for example, to deploy these database versions then to your production system.
I see.
Or you can, but I also saw in some projects that the team implemented something similar with own code. That's obviously also something you can do, which is in place if you have an older application that where basically grew over time and where Liquibase or Flyway weren't introduced in the beginning. Nowadays, I would recommend to use one of these standard tools, obviously.
Mm-hmm. Well, we actually have a question here from our audience for something that we discussed a while ago about the alternative to one-to-many. I'm guessing you're trying to elaborate a little bit on that question, but I guess it was about the recommendation about not using one-to-many when you have multiple objects or multiple rows on that many size, right?
Yeah.
But I think we did answer that question when we say that the alternative would be to not use the mapping, and you could just like query the data directly, either by a native query, or even you can do an entity over that, and then you can join the data directly in memory.
Yeah, but you have different approaches there that you can use. So yeah, first of all, if you have really a lot of records on the many side, I would not model the association as a one-to-many association on the entity. I would just map the many-to-one association and then be fine with that. And then it depends what you want to do. If you want to use that association in a query, in a JPQA query, you can join that from the many to the one side. That is the association that's modeled in the domain model. Or if you are using Hibernate, you can use Hibernate's join syntax to join unassociated entities within your JPQA query. But the most common issue with this approach is that you have the entity on the one side of the association, and you want to get the associations for the entities from the many side. Like you have the order or the product in your product catalog, and you want to get the sold products. In these situations, you would need to implement a query, either a native query where you can do basically everything that SQL is capable of, and then you can map the result either programmatically or with an SQL result set mapping, or you implement a JPQA query and fetch or load the entities on the many side with that one. The huge benefit of using a query there is that you can use pagination to fetch the entities basically in batches. So there's almost, but in most situations, you don't need all of the associated entities at once. The user can handle them. The user has a pagination approach in the UI anyways, and there you would then just use the same pagination in your query to just fetch the first 20 or 50 entities instead of several thousand. I don't know, did I answer the question with that? Or
well, I think so.
Should I go into more details on anything?
No, I think it's okay. Well, we did answer the question. I mean, so it was a question from Anand Kumar. So Anand Kumar, if this is not really clarifier for you, please reach for us again or elaborate more on your question, and we'll be happy to answer it. I think you can even reach Thorben by Twitter.
Yeah, sure.
And he could probably elaborate a little further for you. We don't have much time left. We only have 5 minutes left. Ivan, do you still have a couple of questions left for you? We do like one final question, or
maybe one final question for this installment of our book reading club. So my last question would be about declaring ordering. So you can declare that you want a result list of a particular entity be ordered by placing the order by annotation on a field. But what if I want to have to order by 2 fields? First by one of the fields, then by the next field, then by the third field. Is it supported? Can I do it programmatically, or I should do that in a JPQL?
You can use the same approach. So let me share my screen really quick. So if you know that you will always need the associated entities in a specific order, like in this example, I have a book entity with a many-to-many association. to the authors, and I want to get them in the alphabetical order of their last name. There I can just put an order by annotation on it and provide the attributes that I want to use for ordering in the value attribute. So I can say last name and first name, and there I might want to use a descending order and then an ascending order. So it's basically the same as you would do in a JPA query. The thing you have to be aware of is that Hibernate will add this order by clause to all queries that initialize the author's association. Okay, it's now my test case failed before because I changed the order by annotation, but we can see here this query gets all the associated author entities from the database, and we can see here that now the order by clause first has the last name with descending order, and then the first name with ascending order. So you can just go to the order by annotation and provide as many attributes there as you like.
Okay, great.
Yeah, so I think we are getting to the end of our session. So I would like to thank Thorben for being here with us on our book reading club session when his book Hibernate tips. We're going to have a second session in the next few weeks to review the rest of the book. We'll announce it later on our Meetup website, so stay tuned on meetup.com/virtualjug, and you'll be able to see when the next session is going to be. So other than that, thank you so much for joining us, guys, and we'll see each other again on the next book reading club session. Bye-bye, guys.
Thank you, everyone.
Bye, and thank you for having me.
Bye.
Bye.
Yeah, it was a pleasure.